Welcome to this Programming for Cultural Heritage lecture. Today we're going to talk about APIs and how to use Python to work with them. So an API stands for an Application Programming Interface. It's an acronym, and basically that is just a way of saying a process or a method of interacting with some sort of program somewhere. And so you can have APIs for software that runs on your computer. If you have a certain library on your computer that you're working with, an API interface to it. But more commonly, it refers to a program running on a web server or on the internet. And so APIs have kind of come synonymous to meaning working with a web endpoint and interacting with some web server, exchanging data for some particular reason. And so if we think about what the web is, right, it's a series of files being transmitted over the internet, over HTTP, and you can ask for things, you can post things, there's a couple other verbs you can do. But basically, all the APIs are web URLs that return JSON instead of a web page. So normally you request a website and it sends you a HTML file, and then your browser renders that HTML file. But in this case, it returns a JSON file. And we already talked about JSON. It's basically a Python dictionary. So it returns data to you instead of a web page. And there are two types of requests that are most common that we'll be using. Mostly the GET request, so you're asking for things. And then if you wanted to submit files or submit data to a server, you would do a POST request to send stuff. So there is a built-in way that you could kind of do this work using APIs and then web libraries built into Python. But what we're going to do is actually we're going to use a external module because it makes working with HTTP and API requests very much more easy than using the built-in libraries for Python. And so we are going to install this request module, and basically we're just going to use pip to install it. And there's a whole video on how to do that. So check out that video if you have not yet installed the request module. But once it's installed, you're able to invoke it by just importing that module, and then you can start using it. And of course, you can go to this site and read the documentation about it. But to kind of get started real quick, we can see what we mean by when we say we're using this module to interact with the internet or interact with websites. So if you have if you import the module, you can use it immediately to start making requests of the internet and get data back. So for example, let's do this example together. So if we make a new script, and we're going to we'll save this in our, I'm just going to save it in my downloads. We'll call it API, we'll call it webtest1 or webtest.py. And so what we're going to do is we're going to import the module. And once we have it imported, we can, and we actually should test this first, right? So we're going to test that we actually imported it and it's installed and that we spelled it correctly, right? Requests. So I'm going to run this script really quick to make sure that it is actually, the module is actually there, right? So if you go over to your command line, I'm just going to do the command line version of this and switch between and run them. So Python 3 web test. And so it ran without any errors. If the module was not installed, you would get an immediate error saying it can't find the request module, and you'd know that either you didn't install it correctly with pip or something else was happening there. So we're going to go back and work on this a little more. So now that we have this module, we know for sure it's correctly installed and working as it should. We can make a request, right? So request stores this idea of the requests that you've made in that you can store in a variable. So we'll say r equals requests.get, right? So these are the verbs built into internet activity. So there's a get, there's a post, there's actually a delete, there's actually a put, but mostly we're going to be using get. And so get, we could get anything that we want on web page on the internet. So we'll just get Pratt's homepage, www.pratt.edu. And we'll use HTTPS, right? So HTTPS means it's secure, and most websites nowadays have a HTTPS endpoint, and that's the one you should use because it's secure. So once we do that request, we can have access to a couple pieces of data about the request, right? So every request you make on the internet has a status code associated with it. So most of the time you want to see that you get a status code 200. That means that the request was successful and it was completed, and here's your information. Some of these other request codes are very common, right? So like there's one 404, it's very familiar. 500 means error of some sort. There's a huge range of them that kind of help you debug a specific request. So this idea that this request we just made is now stored in this variable R. And so now R is actually an object that we have these attributes of this request in this variable. So whenever you make a request like this, you can get access to the status code. So this is the 200, 404, 500 request code that we got back. So let's try running it again and see how it works. So right now the Python script talked to the Pratt web server, said, hey, give me your HTML page for this, or give me whatever you're going to send me for this endpoint. And it sent back a 200 saying, okay, it worked. The request was successful. I understood what you were asking for, and I was able to successfully return that file to you, or that response to you. So the other thing we have access to that we're going to use a lot is the text of the request. So the actual, like the body of the text, or the body of the request that came back. And so we just say text. So if we run that again, we'll see that, oh, this is what came back basically. There's a HTML response, right? And so this is basically the HTML of the Pride homepage, right? And so, we've had some experience with XML. You can actually parse this probably with XML, but you probably don't want to. That'd be pretty difficult. But you now have this HTML sent back from the server. And so you can imagine this is basically the same as any API. And instead of sending you HTML pages, it's going to send you data and in the form of JSON. And so really the kind of key of working with APIs becomes working around understanding how that API is structured and how to interact with it. So mostly our workflow is going to be using this request module. We're going to ask for a certain endpoint. It's going to send back that JSON, or that request as JSON data. We're going to parse that JSON data into a Python dictionary, right? Because JSON is just a text string until you parse it into a Python dictionary using the JSON module. And then we have a Python dictionary, and we can do something with the data, the structure of the data, or whatever we want to do with it. So like I was saying, the most important thing to get started with is understanding how the API that you're working with is structured. And there's really no one true kind of documentation for this, right? You have to go to the API documentation for it and read up about it. And so let's do that together for a couple different APIs just to get a sense of what we're dealing with, right? So I provide a list of a number of APIs that are public. And so these are APIs that you could use for your whatever you want to do. And this is it. So, you can come in here and look at some of these APIs and get a sense of what they do. So they break them down by saying, is there auth required? And so if you can imagine, if you're talking to a web page, basically, or a web endpoint, there might be some authentication required, right? So it's not just open to the public. Not everyone can just interact with it, because that might, if it was a very popular service and there was no way to control who has access to it, then everyone would have access to it, and it would probably overrun the server, right? So there's actually, a ways to authenticate your requests, and so there's even commercial providers of APIs. And so a lot of times you need an API key or some sort of like mechanism to authorize yourself to be able to use that API. And so this list is saying, okay, does this API have an auth kind of requirement? The next one is HTTPS, right? We talked about that. Is it over secure socket layer? Is it a secure site? Because if you go to a website and there's that little lock or little green in the URL bar saying the site's secure, Same idea, since this is just the web, you're interacting with web endpoints, you probably want to interact with a secure website, otherwise folks on the internet could see your requests and the contents of your request. So you want to make sure it's HTTPS. And then cores is a little bit more complicated, but it's the idea that there's been security measures put in place in browsers so that one website can't request data from another website and inject that data into the current website. So this is basically a security method that's mostly designed for JavaScript. So if you're doing JavaScript in the browser and there's no core supporter, then your JavaScript application won't be able to talk to this other server. But since we're not doing JavaScript in the browser, we're just doing Python on the command line, this doesn't really matter for us. We don't care if there's cores or not. It doesn't affect us. So we just have to pick an API to kind of dive into the design of the API. So let's look at this. Let's do weather and a weather API. That's pretty benign, right? So here's one that says meta weather. There's no auth required. It's HTTPS and the core. So we didn't cover that, but no auth is good for us. And so I clicked on here, and it basically just dumps us into the API documentation, right? So every API is going to have this kind of documentation defined for it. And basically, it's going to tell you how to use it and what are the endpoints that are available to be used. So for example, it has some examples of a location search endpoint, right? So if you think about the domain of this API, it's weather-based, so you're going to need locations. So how do you represent a location in an API? And so they have an example here saying, okay, if you want to use a location, you either have to pass it a latitude and longitude, or maybe a query, like the word London, right? So if we open this link in a new page, we can see that the result is a JSON result, right? So this is just the API, so you can actually visit these API endpoints in your browser if it doesn't require authentication because it's just a website, right? And so if you wanted to get the location ID for London, you could do it here. Same probably for if you said New York, right? So New York, and it has this ID for it. So you kind of get a sense of like, okay, so the way the system works is that there's a bunch of IDs for locations, and then you can probably get the weather based on that location ID, right? So you would have to have a location ID, and then you can start getting the weather, right? Or you can get information about that location, right? So this is you pass it a location ID, and it will give you information about that specific location. And you can see here it's telling you what fields you would expect to get back from them. Let's look on location day, so you can get information about the location. All right, so we probably want to do location, right? So we can actually build this in our browser before we test it out. So we can see that the base of the URL is always going to be metaweather.com/API, right? That's kind of like the base of it. And then for this new endpoint, we know that we need to have /API location. So we'll add /location. And then it says you add the WOEID, so the location ID for them. And so we have that location ID for New York City. So let's use that one. And if we run that, we'll see it gave back some JSON to us, right? And so this is a dictionary. We can tell there's a curly bracket there. Key value pairs, right? So one of the keys consolidated weather. So it looks like it has a bunch of information about the weather. So it looks like the date is like a 15-day forecast or something, a 7-day forecast, right? So here's today, and here's tomorrow, etc. Right? So it's a dictionary. It's a list of dictionaries, and each dictionary represents a single day. Let's see what else we have in here. We have time. So this must be the time of our request that it was made. It has sunrise and sunset, so that's cool. Like when's the sun gonna rise and set for this location? Parents. So the parent of New York City is New York State, and then it has sources. So where is this weather from? And then some more data about it: time zone, lat long, etc. So just by having this one URL, we can make an API request and get this dictionary back. So let's try this. Let's try doing this. Let's try to request this URL and get some information back from this API. So I'm going to make a new file, call it weather API.py. So the first thing we need to do is import our modules that we're going to be using today. So we know we're going to import our request module, and we know we're going to get data back in JSON, so we should need to import our JSON module too. And so the first thing we need to do is get this data, right? So we need to make a request. So say R, and R is just a variable, right? So it can be whatever we want. We're just calling it R. We could call it weather API request equals request.get, and then what's the URL we want to get. And so this is just the HTTP SURL that we built in the browser just now, and it's just the location API for New York, right? And so let's just make sure this works. Let's print out the status code of this. Make sure we didn't have any typos or anything. Right, so this is just like R was in our previous example. It's just a different variable name, and then the status code, right? That's built into all these requests. So let's give it a run and see what happens. All right, so I came back with 200. So we know that's a good status code. And then let's print out the body of the request, like the text of the request, and see what happens. Right, and so we didn't get HTML back, we got JSON back. This is JSON. And so it's important to know that everything that's coming across the internet is basically a big string, right? It's not really, there's no data types in a HTML page, right? It's all text. And so this JSON string basically came back as text. It's a text string. And so what we can do is use the JSON module to take that text and turn it into a JSON dictionary, which is a Python dictionary, right? And so we know that the data is stored in this weather API request.txt. And we know from our reading and writing JSON lecture that you can access the load and dump methods of the JSON module. And there's actually a loads, and dumps, dump s, which stands for string if you're working with strings. And so instead of loading data from a file, you can load the data from a string. So I'm gonna copy this. This is the weather API text, so that's the data we just printed to the screen. And what we can say is data equals JSON, right? That's our module. And we'll say load S, so we're not loading from a file, we're loading from a string, and this is the string that I want you to parse. And then we'll print out this string, or this result of that operation. So let's see how that works here. Right, it looks very similar, right? But you'll notice there's slight differences, right? This is because now it's not pasting this as a big string, it's actually parsed it into a Python dictionary, and it's available to be used for data, right? So just to reiterate this, right? So we know that there is a consolidated weather key, and that is a list of dictionaries for the day of the week, right? So if we didn't do this part, right, and we tried to, we'll comment this out, and we tried to print out weather API request and that key, right? Let's try running this. Oh, sorry. If we try to, let me undo and show you what I did again. So if we commented this part out, right, and we tried to print just that key without parsing it as JSON, so there's that key. So we know we have the text, right? So if we try to do this and run it, we'll see what happens. And it says, okay, because it's a string, right? It's saying string indexes must be integers, and then you're asking me to send the integer of consolidated weather, and that doesn't exist. So this is not a dictionary, right? That's the whole point of what I'm trying to make. This is still a big piece of text. So we need this JSON loads, and now this data is actually a Python dictionary, and you can talk to one specific piece of the key of that dictionary. Right, so now it's just printing out that consolidated weather list. So let's change that. So since we know it's a list of dictionaries, we could change that to 0, right? Because that's the first one in the list. And run it again. And so now we have just that one dictionary. And if we wanted to, get the weather type, right? So that's stored in this weather state name. And we just, we know this is the first dictionary in the list of dictionaries. So it's a dictionary, so it has key names. So if we change it to add the index and then the key name for that dictionary, we should expect to see just the weather for today, right? Because it's the first one is today's date, right? In showers. So all of that to kind of, we had to navigate the documentation for that specific the specific API and then start figuring out how to use it. And so this is the same situation for all of these kind of different APIs that we are going to be using. So let's try to do this again. We'll do another one from scratch, one that requires us to use the API key and see how far we get with it. So we're going to use the Smithsonian API. That's like a cultural heritage API key, or API that has an API key. And so if we have to discover it first, right, we have to figure out how it works and jump into it. So if we go to, we search Smithsonian, I happen to know that they recently did this open access thing. So they have a Smithsonian open access, they call it, and it's they have an API for it. So we're going to use that. And so it says, okay, here's the open access repository, open access API, etc. So you can access our open access metadata and register an API key with the Smithsonian public API hosted on api.data.gov. Here's the documentation regarding the fields, like the kind of exercise we just went through. All right, so it says the open access API requires the API access key to access the endpoints. Please register with blah, 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 blah. All right, so the first thing we need to do is get an API key to get started. So I'm going to sign up here. Let's see what happens. So it says they're going to email me an API key, and we'll have it available to us. So while that's hopefully processing in the background, let's look at these different types of endpoints that they have available to us. So we have a search endpoint, and we have content endpoint, which is content based on the ID of an object, right? Kind of gives an example of what you would expect to get back from the ID of the object. And so the only other thing we need to do is get our key, and then we can start playing with this API. So let's take a look if it came in the mail. All right, so it did come. I have an API key, and this is kind of what it looks like. All right, so I have an API key, and it's this very long alphanumeric list of code, right? So I have that saved, and now I just need to go back to the documentation and start making these requests, right? All right, so if we wanted to do work with this API, we had to think about like, okay, what do we want to do, right? So it's the Smithsonian, so they have a lot of materials. They have millions and millions of things, right? So there's a reason why they only kind of provide a couple endpoints, right? They provide a content endpoint, and then they also provide a search endpoint, right? So if you kind of think about what you would want to do, is you'd have to search for things that you want, and then once you found the item that you want, you probably want to get more data about that specific item, right? So let's look at the search fields that they have here. So you can send a query parameter. And so if we start thinking about when you're asking for things, you have to not only have, so for the weather API endpoint, it just had one endpoint, right? It's like, here is the data for the New York City location ID. But if you think about something a little bit more dynamic, there's these ideas that you need to send more data to the API endpoint and have different parameters and be able to pass certain things to it, right? And so what we can do is you would have the base endpoint, and then the way you add parameters is by modifying the URL of the request, your base URL. So if you wanted to add a query string, you'd add a query parameter to the URL, and then you provide your search query, right? So the things that you can submit to this API endpoint, search API endpoint, is Q for the query, the start, end, start row, end number of rows, and then you have to always send your API key to the endpoint to validate yourself, to authenticate yourself with them. So let's give it a try, working with the search API endpoint. So the first thing we're going to do, right, is we're going to make a new script for our Smithsonian API work. So we'll make a new one, and we'll call it, in our downloads, we'll call it SI API test.py. So no, like our similar API work, we're going to import the request module and the JSON module to make a request and parse the data. And we are going to just try to get the basic search endpoint working, right? So the basic endpoint says that if we want to do a search, we need to access this URL, right? So let's just access that URL and see what it says back to us as we kind of keep going with the code. So we'll say the request, our request is a GET request, and this is the URL. And let's print out the status code. And let's print out the text of the response, right? So let's give this a run and see how it works. Python 3 SI API test. Okay, so this is the response it gave back. It gave a 403, and then it gave, this is the text of the body. So if we were curious, we could go and actually look up what the error or what the response 403 means. So HTTP status code 403, and that means it's 403 forbidden. Did not, understood the request, but it was not authorized to respond to it. So that means, if we look at the text of the response, it says why, right? It says there's no API key. There's API key missing, right? So the first thing we need to do is apply this API key to the server. And so there's a number of ways of doing this. We're going to do two ways. The first is a simple way to kind of illustrate what it's actually doing, how we're actually building this URI, this URL to the search thing, and then we're going to show a little bit better way of doing it, right? So this is our endpoint. This is the API endpoint that we're going to use. So let's take it out of there, and we're going to call it and make a new variable called API endpoint. Right. So that's our basic API endpoint. And so what we are going to do is we need to add these parameters to this URL to make it pass the data that we want to pass. And the first piece of data that we have to pass is the API key. And so my API key, I still have it here. It's here. Here's this big long string of alphanumeric numbers. And so basically we need to modify the URL to have this API key in it, right? So what we can do is basically whenever you have a URL and you want to pass parameters to the server, you always have the base of the URL, and this is the base of the URL. Then you have a question mark, and then you can start passing parameters separated by an ampersand. This is like, right, this is confusing, but this is just how the standard developed, and it's making it work, and it's kind of getting around some limitations of the URL kind of structure. And so you have a URL, and then you have the question mark at the end, means, okay, the base URL is done. Now there's a question mark, and after the question mark, we're going to do parameters. If you're going to send it a parameter, you need to know the parameter name, right? And so, of course, we can go back to our documentation. The parameter name is API key. So there needs to be a parameter called API key. So if we go back to our code, we can say, okay, so there's the URL. We're going to pass parameters now, and it's going to be called API key. And the API key has a value, and it's this big long thing. So we kind of built up this URL with now this additional parameter built into it. So let's see what it says back to us now that we have an API key. Oh, we have to, we took the URL out of the request and we put it into this variable, so we got to make sure to pass it back to the thing, right? So let's try that again. All right, so we got a different error back, right? It says status 400 error, bad request, one of your params did not pass validation. And so that kind of makes sense, right? Because we only passed API key, we didn't pass any of the other parameters, so it was probably like, I don't know what to do with this request. It's a failure, but I don't know why, because we didn't supply the thing I needed to fulfill the request, right? So we know it worked, so our API key probably worked, right? It kind of went through. And so the next thing we need to do is go back to the documentation and say, like, okay, what else do we need to know here? Okay, there's a Q field. So it's saying if you use the Q field, you can pass it a parameter. The query you would like to issue, query fields accept Boolean operators and or as well field searches. See terms for more field types. So it's basically a way of passing a search string to this API to search their collection of things, right? And so we know that the parameter name is this Q. So if we go back to our code, it's going to be a new parameter, and so we just need to say ampersand. So now this is a new parameter, and that's going to be Q, and it's going to be equal whatever our query is, right? Let's look for cats. All right, so cats. So now we've modified the URL to have this whole 2 parameters being passed to it. Let's head back to our code and run it. All right, so now even more different things, right? Different response. So we're looking at the bottom of it. So if we go back to the top, we can see, okay, there's a status code that we got back, right? We're printing the status code, and there is the data that came back, or the body of the text. So we get a status. So this is the API responding to us. This is not standardized. This is just how the API decides to respond to us, like similar to the weather API, right? So it gave us a status saying, okay, it worked, and then it has a response key, which is it has a rows key, which has a list of dictionaries, very familiar to us. And it looks like these lists of dictionaries are the results of the query, right? So each list or each dictionary has a title, cat filling bride and groom cats. So that's maybe a video. Cat making portrait of cat family. So lots of good cat content here. And it's a postcard we can see from this data here. So this is pretty successful, right? So we can see that it actually returned results. And down at the bottom, it has a row count. So it says it found 19,511 results, right? And so we know there's a lot of results. And so we would want to parse this data now, right? And so before we move on to that, there is kind of a little bit cleaner way of passing these parameters, right? So, because you can imagine this is a little messy trying to build this very long string. What if you had like a very complicated search query and there's like maybe there's an ampersand in the search query and that's going to break the URL because there's multiple ampersands or a question mark or whatever, right? And so there's actually a nicer way of doing this, parsing this um, API request or like passing data to the API, and that's by making this making the parameters separate into its own dictionary and then passing that separately to the request you're making. So that will make a little bit more sense as if we go over it together. So right now we are building this very long API, right? API URL. And so what we want to do is break this down into the individual pieces of the API. And so what we can do is just break this down into its own component parts, right? And so we have the base URL is this thing, that's the base URL. And then we know that this kind of params are going to be a bunch of key value pairs, right? So we have a Q param, which is the query, and then we have the API key, which has our API key. And if you think about that kind of sense of it's like a key value pairing of data, then this makes sense that you can actually represent these parameters as a key value pairing. So we'll say payload, or we'll say params. No, we'll go with payload. So payload is an empty dictionary here. And so we're just going to make our key value pairs. So we have our API key. That's the key. And then the value is actually our API key, right? And then we also have a parameter called Q. And the value in our case was cats. So now we can get rid of this API endpoint, get rid of that. And so now we have broken down our base URL and our payload, or our parameters that we want to pass to the API. And so what you can do is, we know we always need to pass the base URL, so where what URL it's going to use. But now you can also just say params equals this variable. And so what it does is that it takes this information and processes it and combines it with the URL, and now it makes that big long URL for you, and you don't have to kind of like string together big query parameters separated by ampersands, and hopefully it doesn't break. Like what if you want to put a space in there? You know, you're not really supposed to have spaces in URLs, so it has to encode the space. And so by doing it this way, it does all that messiness for you, and it just kind of like seamlessly builds that address for you and works. So let's make sure we did everything correctly. So if we run this again, we should see pretty much exactly the same results, right? Yep, same results, right? So we just kind of simplified our code a little bit, going from that kind of messy string building to just this very nice clean dictionary. All right, so now we know from our previous example what we have to do is parse the data, right? So we can get rid of this stuff, and we'll say data equals JSON loads, right? And then the data that we want to load into it, which is the text of the response. And so we can spend a lot of time playing around with the API, but let's quickly jump through the structure of the data, right? So there's a dictionary as the main response, and then that has a key called response, and that has a key called rows, and then that's where all the data is, right? So knowing that, we can quickly just get to that piece of data, right? So let's try to print out the first item returned, right? So we know that data is our variable, and that's a dictionary, and that dictionary has a key called response, and that dictionary has a key called rows, and then that is a list of dictionaries. So we know from this point on it's going to be 0 through however many things there are. So let's run this, and then we know that this is a dictionary, so it has titles, right? So let's try printing out the title of the first response, right? So let's try to print out that title for the very first one, knowing that this hierarchy that we just talked about. So if we change the code, we know that data is the variable that we're working with, right? And then the first level down is going to be the response, right? That's the first key of the dictionary. So if we change add that to our hierarchy, so data response. And then the second level down we know is going to be rows, which is the key in the response dictionary. So we can add that in. And then the last thing we know is that this is a list of dictionaries, so the first one would be 0. And then since it's a list of dictionaries, each one of these is a dictionary, so then we know that we could reference one of these key values, which would be title, for example. All right, so if we run this now, it's going to do the same API request, pull back all that data, but hopefully only print the very first one, right? It's a little confusing because that's in square brackets, but that title is actually in square brackets. It's not a list. That's just the name of the title. It has brackets in it. So let's do what we always normally do with these types of data structures is loop through them, right? Let's iterate and print out all the titles for this response. And so what we can do, right, is we want to write a for loop. So we'll say for item in, and then we know that this is up to this point is where all the items live. So we can say for each item in this response of rows, each one of these is going to be one of the items in the list. So we could say print item title, right? So if we ran this, we would expect it to show all the titles for the response, right? And so you can see there's a lot of data in there, but there's not really a lot of responses. There's, you know, maybe 10 or 12 responses. But we know there's actually like 15,000 items, right? So there's quite a bit of responses in that results. So if you wanted to access further on results, right? Because this is only the first 10 or 12 responses. And so then you have to start thinking like, okay, how would I reference where I want the responses to start or end, right? And so you'd have to go back to their documentation and see what they have to say about that. And if we go to the documentation, we can see that it says something about just have start and rows. So the start is a number and it's expected to be the start row of your query. So where in the results do you want to start your results to return from, right? And then the size of the array to be returned, default value is 10, so it's 10 things. And then the size range can be 0 through 1,000. So you can actually get 1,000 things back, right? So let's modify our code to use one of these rows first. And we'll say, okay, so this is a new parameter, right? It's just like the API key or the queue query parameter. It's just a key value pair, right? So rows, copied too much, rows, and this is going to be a number, and it says it could be 0 through 1,000. So let's say, yeah, we'll take 1,000 things, please. And let's see if that looks any different if we run the code again. All right. Yeah, right. So it went through many more things, right? There's 1,000 things in here now. So it returned 1,000 results instead of just the first 10 things. So you could also say, okay, you could start thinking about how you would navigate this result set. Say you wanted the first 10,000 things. That means you'd need to make 10 requests, right? So each request would be 1,000 things returned, and then you need to offset where the next one would start, right? So your next one would say, okay, documentation says that if you want to add another parameter to tell it where to start, then you need to add the start parameter. So you would say, okay, start. And this should go for, let's start off on the 1,000th row, right? So return 1,000 rows from the 1,000th row. So you get the next 2,000 things, right? And so if you ran that, you would probably look very similar, right? because it's hard to tell. But if we run it again, we get different results, right? Lots of scientific names of animals here. So you'd have to explore the data some more, right? So there's a lot of good information in the field, that response, and sometimes you can look at the documentation for the content to see what comes back. But oftentimes it's better to look at the response itself, right? Because it's not telling you what keys are actually going to be coming back with in the search results. It's just saying, here's an example response, right? It's kind of giving you the structure. It's not giving you the specific pieces of the keys that are actually in there. So you might want to just play around with the code, right, and go through and just print, and go through and print the, instead of just the title, just play around and print the whole thing and see what it comes back. See if anything catches your eye. You can always also make this a little bit more formatted for your screen. And so right now, this item is it's actually a Python dictionary. So when you print it to the screen, it tries its best to format it. But you can actually convert it back to a JSON string, and strings are much better to be displayed on the screen because it knows exactly how to display it, right? And so instead of printing the item, you could actually say, okay, actually don't print. So if you were going to be printing that item, you could say, okay, actually don't print the item itself. I want you to print the JSON representation of it. So you're actually kind of converting it back into JSON for display purposes. So you can say JSON dot dump with an S means dump this to the string, and do that for the item. And so if you ran this, you would see that it is very similar looking to the previous run, right? It has double quotation marks instead of single ones, and you're like, well, this is not helpful, thank you. But actually, this Json Dumps has a pretty print method built into it, or option built into it. So you can say indent and then number of indentations you want, and it will actually format the string for you, and that will make it much easier to look at on the screen when you print it out. So let's save that and run it again and see how it looks. And so now it's printing each item as a parse JSON pre-printed indented item. So now you can really come in here and see all these stuff that's in here, right? So you actually have the record ID number, you have the URL, it looks like, to go to the item itself. You have the name, the title, you have metadata usage, so what, like, is it public domain, is it open, etc. You have the data source, so what Smithsonian Institute did it come from, and then you have a whole bunch of more structured stuff in here. Like probably not all results from the Smithsonian are going to have a taxidermic family, right, or tax family or phylum. So this is obviously from the Natural History Museum, so this thing does have these pieces of metadata. So that's not necessarily going to be there for everything, but it is specifically for these things. So you would have to, just looking at the field, to know what was actually coming back. So there's all sorts of stuff in here, right? You just have to play around with what you're trying to get back and what your query is going to be. So the challenge this week is to continue on using this API, or try to get it working on your own, and try to do something interesting with it. You could search for certain things, try to make more advanced queries to see if you can do the Boolean operations they were talking about. Try to pull out different things and try to save certain sets of pieces of data, right? So let's do that as a kind of a final example, just to give an example of doing this kind of like saving data for later. So say you had you're doing some sort of research on these sort of taxidermic animals, and you wanted to only pull out certain whenever the certain phylum is provided, right? So you need to say, like, you need to check a piece of data, right? And then you need to actually save that piece of data for later and dump it out somewhere, right? And so if we look at this structure, the first thing we want to do is, like, well, let's try to focus in on that one piece of data that we actually want to to filter on, right? So for example, we can see that this phylum is stored in tax phylum, which is stored in index structure, which is stored in content, right? So let's just try to print that out if we can. So let's go back to our code, and we know that we'll comment this out, right? We don't need to, well, we'll leave it in there for now, and we'll print it out. So this is kind of nice because we'll kind of like print out the structure, and then we'll try to print out the piece that just we want, and if we run into any errors, we'll know what was wrong with the structure. So let's print out the item, right? That's the data, and that has a key called content, and then that content key has a field called index structured, right? And then that will go after there, index structured. And then that is another dictionary. So it has its own key called tax phylum. And we can add that to our list. And so let's just run this and see how far we get. All right, so it looked like it crashed from the very first one, right? So it came in and it tried to find this piece of data that we're talking about. It tried to go into the index structured, and it tried to go into the tax phylum, and this is not a natural history. This is from the National Museum of American History, so this doesn't have a tax phylum, right? So it came in here and said, "Oop, tax phylum, key error, not found," right? So what we need to do is check for that, right? Check if that key exists before we actually assume that it's going to be there. So what you can do, right, is we probably are pretty confident that structured data is going to be there all the time, right? It's always going to be, at least have this content, and there's going to be some index structured information there. But what we're finding is that tax phylum is not always there, right? So what we can do is we can put an if statement, right? So we can say, you know what, check if this key exists, right? So only check if tax phylum is in this dictionary. And if it is, then do the stuff we were wanting to do before, right? So we're pretty confident these two levels will be there always because it seems to be there for everything, but we don't know if this tax phylum is, it's not there all the time. It's only there for some records. So we're saying if this key is in this dictionary, then continue on to do what you were doing before, right? So let's get rid of this, save it, and try to run it again. Right, and so no error. So it went through all 1,000 of those things, and it looked for results that only had that tax formula that we were looking for, right? So next thing we would do is like, okay, so this is maybe the smaller data set that we want to use for later, so we would want to save this somehow, right? And so we did this before, but to save stuff, we need to have a place to put it, right? We need to save it into an empty place. So we'll make a new empty list up here. So we'll say save data equals this, right? And if that is, if we get to this point, then we know it has the specific tax phylum key, but we actually haven't tested it, right? So we know it's there, but we actually haven't tested it for exactly what we wanted. So we have to add another, we can add another if statement here and say like if blah, blah, blah tax phylum is actually equal to the thing we're looking for. And let's make sure this makes sense. If we look at the data, if it equals to this core data value, then we want to keep it, right? Maybe this is one of the things that we want to keep. But this is very tricky because if you look here at the data results, you see these square brackets, right? And these square brackets means that this is actually not a string, it's a list of things, right? And there could be many phylums for this entry, right? Or there could potentially be, right? So we actually don't want to test to see if it is straight equal to it, but we want to test to see that if that value is in the list, right? So we have to say instead of equals, we have to say if the thing we're looking for is in this list of things, because we know this is a list, then do this part. So now I'll count. So if we take a look at this, we're not going to do straight equal signs, right? We're not going to say, because if we say if this equals to Chordata, it's not going to be true because it's not a single string, right? It's a list of strings potentially. So we have to say, okay, if this is not double equals, but if it is actually in that list. So we can say if the thing we're looking for is in this list, then do the next part. So let's comment out this JSON dumps, and we'll just print out the file for each thing in the results, right? And hopefully it should say all be the same one. Right, so there is a number of resources. There's one where there's in two categories. I'm not sure how that would work, but okay. Um, and so we want to uh, save these for later, right? So say we want to go through all of the results and save them for later, and output them into its own JSON file that we want to work with later, right? And so the kind of thing with working with APIs is that we don't really want to have to keep doing the same request over and over and over again, right? Because if we do this request, every time we do this request, we have to talk to the server. The server has to do its database thing and send us back this data, and then we do something with it. So we kind of want to think about our work with APIs in maybe twofold, right? So some API work just has to be done in real time, right? If you're querying for the status of a city bike dock, right? You don't want to save that data for later because it's going to be useless data, right? The city bike dock is going to be empty from 1 hour to the next, or change the status from 1 hour to the next. So those sorts of APIs are dependent on being in real time, right? Things like Twitter, things like those sort of social media, they're real time APIs. But for something like this, where you're processing data, you don't, it's not going to change, right, from one day to the next, really. They might add more stuff, but really, if you query it today and then work on the data tomorrow, there's not going to be a big difference. But it would be a problem because if you wanted to do all 15,000 of these items results, you'd have to go through each and every response and then process the data. And it would work, but it's nicer just to like save the data you want to use for later and then just use that file for your processing, your analysis, etc., right? So we did this similarly with the CSV, parsing a huge CSV down to just a small piece of it or a subset of it. So it's kind of a similar idea. So if we know that this item is in the right phylum, then we want to save it for later. That's kind of like our research question right now. So we have the saved data, and the only thing we need to do is just add this item to our saved data. So we know we can add items to lists using the append method, and we're just going to append that item. And so now this is our kind of saved list of things, and we can now go through the whole results, and at the end of it, we'll have just our data that is matching our criteria that we want to save out to a different place. And so we know that we could save this out using our Json Dump command, right? So we can say with open, and we'll call this file chordata.json. We're going to open it for writes mode as out, and we'll say json.dump out, or we have to pass two things: what we want to save out, which is the saved data list, and then where we want to put it, which is out. And then we can even do that indentation thing here too, right? Make it a little bit nicer. So if we run this again, we should hopefully see a new file in our directory. Oh, you need to spell JSON correctly. All right, so save that out, and so hopefully if we pulled that data into our editor, this is that file that was just created, we can see this is now like a subset of that data that we created or we queried for, and it all has the exact should have the same file for everything, right? That we're specifically looking for. So that was just an arbitrary kind of decision to make. Just look for something. You probably want to have maybe multiple multiple aspects to that, right? To figure out what you want to do. And there's even some content in here, like here's a high resolution JPEG of this specific result, right? So let's see what it looks like. It looks like this. It pulled this back. So there is a skeleton. So the only other aspect of this that we haven't really talked about is that we talked a little bit about pagination, right? So this is the first, we're receiving the first 1,000 rows. So if you wanted to do kind of go through all of the data, right? So you'd have to make multiple requests. So that's something you could try to work on and try to think about how would you write a for loop that loops through all the different requests and offsets each by 1,000 so you get all the results, right? Because we saw in the very beginning there's actually like 15,000 results for this query, and you might want to look through all 15,000 results and not just stop at the first 1,000, right? So you have to play around with that and think about how you could structure this script so it actually makes this request and then offsets it by passing different query parameters. But this should get you started working with APIs. You can, for this week's challenge, you could stay with the Smithsonian API, or there is in the slides a link to a bunch of other APIs that you could try playing around with. But with this, if you kind of get this basic knowledge down of making these requests and parsing the data and then looping through, you're on a good start to start working with JSON and APIs. So thanks for watching, and I will talk to you later. Bye.